Hello everyone and welcome to GIS. Today in this video you will learn what is data in GIS, types of data, spatial data, vector data, raster data. Also you will learn the representation of vector and raster data. And lastly you will learn non-spatial data. So at first let us understand what is data in GIS. Data is one of the most important component in GIS, where we can say 80% of the task is going to be completed if we collect the data properties. So you need to understand which type of data is used in GIS and which type of data is needed to be collected. Data is basically a collection of facts and figures about an object. In the phenomena, let's say for example, collection of latitude and longitude of your house. It is often most expensive component in GIS. So here is the chart of types of data. Data is mainly divided into two parts, spatial data and non-spatial data. Spatial data is further divided into two subparts, that is vector and raster data. Now let us understand what is facial data. Facial data is usually stored as coordinates and topology, and is the data that can be mapped. Data that defines the location of geographic feature. Say for example, a geographic feature may be any features, such as mountain L. If we define the latitude and longitude of the mountain, it is known as spatial data. Spatial data is the physical representation of the Earth's feature. It represents the location, size, and shape of the object in the earth. That is building pond, mountain, administration, and boundaries, roads, river, etc. As you know that every element is special in nature. So we can describe any element of the world in two ways. First is locational information. In this we'll find the coordinate. That is the latitude and longitudinal address of the tree. Basically, we'll find where the tree is located. And the second way to describe any element of our world is the attributional information. That is the species height, age of the tree. The attributional information is in the tabular form. In GIS, there are two primary ways that the spatial data is modeled. First is raster and the second is vector. A vector system usually stores data as coordinates. For example, each uniform area is surrounded by a set of straight line segment called vector. A vector-based GIS defines the vectoral representation of its geographic data. The three main geometric shapes used in vector data model to represent the real-world feature are point, line, and polygon. So let's understand the first type of feature. That is point. Point is a zero-dimensional object that contains only single x. Y coordinate pairs points are typically used to model singular or discrete features such as small building, well power poles, temples, trees, etc. Points have only the properties of locations. The second feature is lines. Lines are a one-dimensional feature, comprises of multiple connected points. Lines are used to represent linear features, such as road streams, street central line, etc. Lines have the property of length. A line is synonymous with an arc. The third feature is polygon. Polygon are a two-dimensional feature created by multiple lines, which create a closed polygon. Polygon are used to represent features such as lake, huge buildings, vegetation, communities, etc. Polygon have the properties of area and perimeter. Polygon are also known as area. The second type of data is raster data. Raster data is made up of matrix of pixels or cells, and each pixels have an associated value, a value given to each cell, which informs the users which entities is present in which cell. For example, the value may represent elevation above the sea level, rivers, etc. Example of raster dataset is digital aerial photograph. Satellite image, digital pictures, that is the picture taken on camera or cell phone. Thousands or millions of individual picture. Element or pixels. When we zoom into the digital image, you begin to see each of the individual pixels that make up the image. In case of aerial or satellite imagery, each of these pixels contain number that represents the amount of light at a particular wavelength that was recorded by the camera and is now being displayed by the computer monitor. First type of feature is point. A point in vector data is represented by a single dot, whereas in raster data, it is represented by a single cell. The example of points are trees, temples, etc. The second type of feature is line. A line in vector data is represented by a set of points that make up a straight line or a curve depending upon the feature it represents. Whereas in raster data, it is represented by a sequence of cells or grids. The example of lines are rivers, street central line, etc. Third is polygon. A polygon in vector data is represented by a set of line, which creates a closed figure, whereas in raster data, it is represented by a zone of cells. The example of polygon may be lakes, large city islands, etc. Now, the last type of data that is non-spatial data. Non-spatial data is also known as attribute or characteristics data. Non-spatial data are stored in GIS as tables. Such tables are known as non-spatial or attribute tables. Non-spatial tables are represented by rows and columns, in which each row shows a spatial feature and each column represent a characteristics. The intersection of rows and columns gives the value of specific characteristics for a particular feature, as you can see in the table. A row is known as records, and a column is known as fields or items. So that's all. I hope you liked the video. Stay tuned.